So let us have a closer look at the temperature and salinity distribution across. These are vertical transects. Okay, the vertical axis is depth. The horizontal axis is distance, and we start near the Bering Strait. This is the connection to the Pacific Ocean. Yeah, very, very shallow. We start in the Canadian Basin and then cut through the Eurasian Basin. We end up in Fram Strait, end up in the Greenland Sea and the Norwegian Sea. Okay. And the top image shows you the temperature distribution, and below that is the salinity distribution. So we can identify key features when you from the structures that are shown here. One feature that immediately springs to mind is deep convection in the Greenland Sea. You can see the features here in this, okay, deep convective mixing. Okay. And this is facilitated by a preconditioning process. Preconditioning process means already weak density stratification, okay, between the surface and the bottom layers, and then you have a cold air outbreaks. And indeed, the Greenland Sea is most of the time ice-free, so you have a direct connection to the atmosphere. No insulation by ice cover or whatsoever, and you can have very, very large heat loss, very high cooling rates in that region. That's one feature that you see. The other feature that you can see this layer marked in green. It's a warm water that you observe throughout the entire region here. This is the Atlantic layer. Indeed, in salinity, you can see that near the surface it gets very, very low, the salinity. And you can see the highest salinity near the bottom. And this is essentially comes from slope convection that takes place during winter in polynyas, and where you actually move a cold and saline water is moved into these deep basins. Okay? But in the deep basins, there is not a free connection, okay, because you have the silts, and you can see the blockage of these silts here. This is the Lomonosov Ridge, which is pretty, reaches up to almost 1.5 kilometers below the surface, and you can see that there is no direct through flow. All right, so this is what we're talking about. This is what we call the Arctic Ocean, okay, plus the so-called Jensey's connection. Okay.